We're given here that triangle LKN and triangle NML are right triangles. Then segment LK is congruent to segment NM. We prove that triangle LKN is congruent to triangle NML. So let's draw that. Say, drawing. Okay, that one, and then the other one is, should look like this. Are they proportion? Okay. Can you see my drawing? So this is L, M, N, K. And it says they are triangle LKN. This is a right triangle, and then NML, as well as this one. And then this one. Ah, okay, so that's your drawing. Not from the given. Okay, but it's given that LK is congruent to NM. So we already knew that one of the legs of each of the triangles are congruent. So we write the given, and then LN, this one, LN, should be congruent. Okay, by reflexive property of equality. And LN is also the hypotenuse of each of the triangles. Yeah, since it is given that one of the legs, LK and MN, are congruent, and the hypotenuses are congruent. Therefore, this is hypotenuse leg. Okay, hypotenuse leg congruence. Do we have to do number 10? Okay, I'll look for problems. Okay, for isosceles triangles, you know what an isosceles triangle is. So isosceles triangles, so that means two sides are congruent, and the bases are also congruent. So there are three types of isosceles triangle. Three types. This is isosceles triangle. Then three types. We have the acute, obtuse, acute meaning the angle is less than 90 degrees. Obtuse, the angle included is greater than 90 degrees. And right, that is exactly 90 degrees. So this one, for isosceles, okay, this one, they are congruent. Okay, this is less than 90 degrees. This is greater than 90 degrees. And this is exactly equal to 90 degrees. I hope that's what your teacher meant, and not the proving part. Okay. Okay. Classify triangle ABC by its sides. You classify. So if you're given like the sides, you classify the type of triangle. Follow-up questions. Triangle ABC, a right triangle. Okay, find the measure of you use the Pythagorean theorem to solve for the sides. Yes, you can also use the distance formula in identifying triangles. So maybe I can give you, okay, no problem with that. Okay, find the measure of exterior, what's that? Exterior what? Okay, exterior angle. Okay, so this one is the given triangle with an exterior angle. The exterior angle is this one. And we're given 53 degrees and 56 degrees. All right. Yeah, you need to find the measure of the other one first, this one. And you know the measure of the sum of the measure of the angles in a triangle is equal to 180 degrees. So that would be 180 degrees minus 53 minus 56 degrees. Let's say this is x, so this is equal to x. And you can find 1. So what is x here? 180 minus 53 minus 56. $71. And this one is a straight line, right? So that means the measure of this is 180. So x plus 1 is 180. 71 plus angle 1 equals 180. Yes, therefore angle 1 is equal to 180 degrees minus 71. So that is how to solve it if you don't know the rules. So your teacher here solved this problem using the rules. Like say if you're given 2 angles in a triangle, then that one, the sum of that is equal to the exterior angle. But if you don't know that, then you can solve it this way. Okay? Then the other one, you solve for the exterior angle, and you solve for x first. So no question on the first problem. Okay. Yeah. The other one, okay. This one. So you're given this triangle and then exterior angle. Is this 40 degrees? And this one is 8x minus 5. 5x plus 15 degrees. Okay, the same. If we use the rules, so the sum of the interior angles of a triangle, 40 plus 5x plus 15 equals 8x minus 5. And you solve for x. Solve for x. We remove the parentheses. 8x minus 5. We group like terms. 40 plus 15, that is 55. So 5x plus 55. 8x minus 5. Then we group 5x and 8x. Yeah? We transpose 8x to the left. That would become minus 8x. Then we transpose 55 to the right to become minus 55. So this would become negative 3x equals negative 60. Then we divide both sides by negative 3. Therefore, x is negative 60 divided by negative 3 is positive 20. So the value of x is 20. Then we substitute 8x minus 5 is 8 times 20 minus 5. So what is 8 times 20? 160 minus 5, then 155. Therefore, this angle is 155 degrees. And you can also solve for this. This is 5 times 20 plus 5. You just plug in the value of x there. So this is 100 plus 15, 115. Okay, no problem with that. And no problem with classifying the triangles. Right. The proving part, you don't have any problems. Okay. What else? You have to make sure you know all the types of triangles. Equilateral, isosceles, scalene, none of this. Classifying, what's that? Okay. Okay, I think it's the same. The obtuse, the types of angles, triangles. When you classify triangles by sides and angles, so you should identify whether it's scalene, acute, isosceles, obtuse, equilateral. Corresponding parts of congruent. Okay. You can upload here. Corresponding parts of congruent triangles are congruent. CPCTC. Okay. Let me take a look. Polygons. A triangle PQR is congruent to triangle STV, congruent, just, okay, corresponding parts. This is what I said, corresponding parts of congruent triangles are congruent. So angle Q, where's that? Angle, where's the drawing of the first one? The 5.2. Angle Q is congruent to angle T. Angle P is not there, right? So this is just similar to the one that we proved. Say the first one. The first one. Okay, is that okay? This one and that one. So the first one is triangle. Was that ABC? ABD. Okay, this one. So you need to prove whether the two triangles are congruent. But I'm trying to draw it here so it'll be real clear. So this is A, B, D, C. So this is also B, D. BD is congruent to BD. So it's given. And then angle ADB is congruent to DBC. These are alternating angles. And then ABD is congruent to CDB. So what's the question here? Yes, they are, because you've already proven the two triangles, so two angles are congruent, and to one side, this one. So that is ASA. This is ASA. Or you don't need to. We don't need to state. There's another example here. I did hear you. Then the other one. The other one is, okay, this one. Yeah, I lost you. Yeah, the other one is this one, TU, V, W. Maybe this one is X. Yeah, so it's given here that this one is angle 1 and 54, 80 degrees. So we need to prove that, find the measure of angle 1. You don't need to prove. So this one is, these are vertical angles. Therefore, this one is also 54. Yeah. And if we're going to extend this, yeah, extend. So these are alternating angles. This one and this one. Yeah. Or you can find this one and then you find angle 1. So if you find the measure of angle U, find the measure of angle U, then you can solve for angle 1, since the measure of angle U is equal to the measure of angle 1. Plus, yes, or you can do like this, 80 degrees plus 54 degrees plus the measure of angle U equals 180 degrees. So the measure of angle U is equal to 180 degrees minus, what is 80 and 54? That is 134. 134. Then the measure of angle U would be the measure of angle 1. Okay. Yeah, 46. Therefore, angle 1 is also 46 degrees. Yeah. I hope you'll get, you're welcome. I hope you'll get a perfect score. Yeah, I want you to get a perfect score, really. You're welcome. You have a great night. Good luck on your exam, Sydney. Bye.